Okay, in this video I want to take a look at performing multiple transformations to a single trig function. So here I've got y equals negative 2 plus 3 sine x. Let's make that a little darker. There we go. Okay. So I can see I'm doing two different things. I'm multiplying by 3 and I'm also adding a negative 2. Now both of those I'm doing after I evaluate the sine function. So both of those are going to affect things vertically. So I'm going to work through graphing this, and I'm actually going to show you two different ways to do it. One is to fall back on what we've been doing, which is to create a table of values. So I could say x, and then sine x, and then 3 sine x, and then negative 2 plus 3 sine x. Because essentially this table of values is just keeping track of how I would evaluate this. I would take an x value, I would figure out what the sine was, I would multiply that by 3, and then I would add a negative 2 or subtract a 2. And I'm going to set my x values equal to my quadrantal angles. So sine of 0 is 0. 0 times 3 is 0. Negative 2 plus 0 is negative 2. Sine of pi over 2 is 1. 3 times 1 is 3. Negative 2 plus 3 is positive 1. Sine of pi is 0. 3 times 0 is 0. Negative 2 plus 0 is negative 2. Sine of 3 pi over 2 is negative 1. 3 times negative 1 is negative 3. Negative 2 plus negative 3 is negative 5. Sine of 2 pi is 0. 3 times 0 is 0. Negative 2 plus 0 is negative 2. So I've got my table of values. And if I'm going to graph this, I'm just graphing my x values, and then this formula gives me my y values. These were just intermediate steps. Okay, so I can say, let's see, I'm going to mark up my quadrantal angles. And it looks like the values that I care about are all negative, so actually I maybe wanted to draw this a little higher up so that I have some more room here on the board. Okay, give myself some more room below the x-axis there. So here's pi over 2, pi, 3 pi over 2, 2 pi. Looks like the y values we care about are negative 2, positive 1, and negative 5. So I find it helpful, although it's not necessary, I find it helpful to just draw in dotted lines. These are like the grid lines on graph paper at those heights. And then I'm able to say that sine, looks like we're going to start at the middle value, and then go up to a high value, down to a middle, down to a low, back to a middle, and there's my sine function right there. Now, every change that I made was a vertical change, so that did not affect the period. That's still 2 pi, but my amplitude did change. The amplitude is the vertical distance between middle value and high value. Looks like that's going to be 3. Okay. All right, I'm going to show you a nifty shortcut for getting to the same basic thing here. And you can decide which way you're most comfortable with. Okay. But I can see I'm basically doing two things here. I'm multiplying by 3 and then I'm subtracting 2. And I know that with a sine graph, it would start with a high of 1, a middle of 0, and a low value of negative 1. And with these vertical transformations, I'm going to keep track of things in exactly the same order I did for this table of values, which is the same order in which I would evaluate things. So I'm going to multiply things by 3. Now when I do that, what that's going to do is that's going to stretch that high value up to 3 and that low value down to negative 3. So that's performing my vertical stretch. And then I'm going to subtract 2, and that's going to shift everything down 2. So negative 3 gets moved down to negative 5, 0 gets moved down to -2, 3 gets moved down to 1. These are my new high, middle, and low values. And notice I got all of that very, very quickly. I wasn't changing the x values, so I can just mark off the usual x values that I would mark off and get this vertical transformation. Okay. So I'm going to put another one up on the board, and while I'm then erasing the rest of the board, you can pause the video and see if you can get this. Use a table of values if you like. Use the shortcut if you like. Let's try y equals -2 minus 5. Oh, we'll do this one as a cosine. 5 cosine of x. And I'll just caution you that that's a negative right there. They're both negative, actually. But we're multiplying not just by 5, but by -5 here. So we want to remember what that does. Okay? So go ahead and pause the video while I get the board erased. And then when you come back, I'll have the board erased, and we can look through it together. Okay, so I'm going to try this one just using my shortcut. Okay, this is a transformation of cosine, and it's everything that I'm doing after I evaluate cosine, so it's going to be vertical changes. So I know that cosine usually has a high value of 1, middle of 0, and a low value of -1. First thing I'm doing to that is multiplying by a -5. Now, that's kind of interesting because I'm basically putting a y-axis here, and I don't want to put -5 up here and +5 down here because that doesn't make sense. That's not how they actually look. So I'm going to say when I multiply 1 by -5, I get -5. When I multiply 0 by -5, I get 0. When I multiply -1 by -5, I get +5. But you'll notice, sort of flipped. The high value here became the low value here. And if we remember, when we multiply by a negative number, that does do a vertical flip for us. So to help me remember that, because I can sort of make a mental note, but I know that the usual graph for cosine starts high and starts going down. If I flip it, I'm going to start at a low value going up. So that's how I'm going to just annotate this so that I remember that I'm flipping it as well as stretching it by a factor of 5. And then I'm moving everything down 2. So my high value will be 3, middle is -2, and low value is -7. I'm usually not too concerned with drawing this exactly to scale. I'm just sort of keeping track of what my important points are. So now I'm ready to graph. Haven't done any horizontal changes, so I know I'm just looking at my quadrantal angles, pi over 2 pi, 3 pi over 2, and 2 pi. We're still starting at a low value and going up. So let's mark off our high, our middle, and our low. So it looks like our high value is 3. Our middle value is -2. And our low value is -7. And we're supposed to start low. Next important angle, we're at a middle value of -2. Then we're at a high value, then a middle value, then a low value. Connect the dots with a nice smooth curve. Don't forget your arrows because it keeps going. And now we've done 2 vertical transformations. In general, if you have y equals c plus a cosine x, or y equals c plus a sine x, okay, the amplitude is the absolute value of a. That's how much you've stretched or shrunk things. And of course, if a is negative, that means you've done a vertical flip as well. The vertical shift is going to be the absolute value of c units. Here, c was -2. We shifted things 2 down. Okay, so we shifted things the absolute value of -2, which is 2. It would be up if C is positive, and down if C is negative. So that sort of summarizes all of our vertical transformations for us. Next video, we'll take a look at what if we're doing multiple horizontal transformations, and then we'll try putting all of them together.